Hello, everybody. At a student's request, I thought I would make some solutions to the quiz review set. Seemed like a good idea. So let's dive right in. Here's the problem. Let's say we have this code where we're drawing a whole bunch of ellipses. A good programming practice is being able to take advantage of patterns to make your code more concise. And so here I'm noticing that the second argument is all zeros, the third argument is all tens, the fourth argument is always tens. So the only thing that's really changing here is the first argument, the first input. So I can use a loop, taking advantage of this pattern where we're increasing by 5 with every iteration, to rewrite this in a much shorter way. So let's go ahead and do it. I'll start by just copying and pasting this. Here I'm imagining that we actually have an ellipse command. As you can see, there's a compile time error. So let me just create a temporary method just for the purposes of this exercise so we can run it and see what's happening. And then I'll just have it do something. So ellipse at, and then I'll say an x coordinate and a y coordinate and size, width by height. Okay. So what it does right now when I run it is it will print however many ellipse statements there are here. Just let it do it. Okay, great. So we're displaying ellipses at these various coordinates with various sizes. Okay, so let's encapsulate this in its own method. So original, or like let's say print original. Just because I want that code to be present, but I want to be able to comment it all out easily. And let's now try and do an improved version. So one thing that might occur to you to do is let's make this thing a variable. Let's first decide how many times we're going to loop. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we could decide we're going to loop 10 times. So I will go from 0 to 10. And we'll have the ellipse statement. Oops. I'll just type it. We'll have the ellipse statement with an x variable that I'm going to create in a second. And this is always 0, and that's always 10, and that's always 10. And then here I can say int x is 5. And then, so for the first iteration of the loop, this will be 5. And then I'll say x plus equals 5. Plus equals 5 just means the same thing as x equals x plus 5. It's just a shorter syntax for that. And so now every single loop, I'm going to increment x by 5. So if I run it again, hopefully we'll see that it outputs the same thing. Oops, it won't output the same thing because I forgot the semicolon. Let's do it again. Okay, great. So it has done the same thing. And I just wanted to check the last condition. So the last one really does end with an x coordinate of 50. So that totally works. A different thing we could have done is rather than have this separate variable x, we could have called the loop variable x. And instead of being a loop counter that just counts how many times we're going to repeat, instead we'll have it start with 5. We'll have it go up to the value of 50, but we want x to possibly include 50. And then each time we'll add 5 to x. And so now this is going to do the exact same thing, only it's even a little bit shorter, a little bit nicer. So you can see it's done the same thing. Okay, so let's do the next one. So in the next one, I see groupings of 4 ellipse statements each. And in each grouping of 4, the first argument goes 10, 20, 30, 40. Whoops, 0, 10, 20, 30. The second argument is the same within groups, but from one group to the next, it increases by 10 each time. So let's try and do that. So we'll start off just by pasting the original problem. Let's start this way. So I noticed that there are how many groups? 1, 2, 3, 4 groupings. So let's loop 4 times. I goes from 0 up to 4. In each loop, I'll have those same 4. Let's delete these all now. So 0, 10, 20, 30 is the same for each grouping of 4. 10 is the same, 10 is the same. So the only thing that changes is this y value. So just like last time, I could have int y equals 0, and then y plus equals 10. And then this can be Why? Maybe I should sound more excited. Why? So now the first iteration, these will be zeros, but then the next time we go back to the top of the loop, they'll all be 10, and then 20, and then 30. So let's run it and make sure that that displays what we want it to. So you can, if you want, you can pause and sort of ponder, but this is correct. Let's do the same thing we did last time. Instead of calling this I and having it be a loop counter, we'll just have it be the y variable directly. So we want it to go up to and including 30, and each time we'll have it increase by 10. And so now let's run it again. And we see that it's done the same thing. So that looks good. And if we wanted to, we could even have one more loop, because there is a consistent pattern between these four. Y is always the same, 10 and 10 are always the same, but the x coordinate goes from 10 up to 30. So let's do that. Let's write another for loop on the inside where x is going to start at 0, it's going to go up to 30, and it's also going to increase by 10 each time. And let's put that inside the loop. And so now the way to read this is for each value of y in this outer loop, the inner loop is going to entirely complete. So it's going to go through all of the x values defined here for each of the outer values y. Here, let's actually put the x in. So, well, actually here we can actually look and see with the debugger. So if you click in the margin, that will add a break, what's called a breakpoint. And then you can hit the little bug button up here. And this runs in debug mode, which we'll talk about more when class comes. But it's a useful thing to do. So the program is running right now, but it's paused on this line of code. And each time I hit this button, it's going to execute the next step in the program. So it's like I can run the program one step at a time. So I hit it, and you see right now the y value is 0. And then I'll execute one more line, and the x value is 0. So now we're on line 8, and x and y are both 0. Now I'm just about to hit it a bunch of times, and what I want you to notice is we do all of the iterations of the for loop. So the x value is going to go up by 10 for each iteration. But the y value is going to stay fixed at 0 because we haven't yet got to the end of that outside loop. And we have to get to the end of the outside loop before it will go back and add 10 for y. Okay, so here we go. So you see I'm going through several iterations, and the y value is still 0, but the x value has been increasing. And I think you should also do this on your own, and you can do it a little more slowly so that you can see it. And so now that we've done all 4 iterations of the inside loop, it didn't show us getting down to this closing brace, but it went back to the top. So now we're back at y equals 0, and now you can see, we've added 10 to y, because that's what happens after you go back up for the next iteration of your loop. So now x starts over again at 0 because we're starting this inner loop again for the first time. So now as y is 10, x is going to go from 0, 10, 20, 30. So you can see y is still 10, now x is 10, now x is 20, now x is 30, y is still 10. And now we're done with the loop. And so now y goes to 20, and as y is 20, x is going to go from 0 to 10 to 20 to 30. So several people said they were uncomfortable with nested loops. I think the thing to remember, in my mind, I have this phrase: for each value that this outer loop variable takes, you do all of the looping for the inner variable before you go back up to the next value of the outer variable. And that's how you trace it. All right, so let's stop it. And so I think for my money, this is kind of the shortest, best answer to this exercise. Okay, without a computer, decide what these fragments will output. So the difference between print and print line, that's what this ln is about, is print line will display whatever the argument is, and then after it's displayed, it will also insert a new line character, which will move the cursor to the next line. So if I'm going to predict my answer here, is the solutions? Yes. So when we have print 1, that'll print the digit 1, but I won't go to the next line. Print 2 will display the digit 2, but I won't go to the next line. Print line 3 will display the digit 3 and then go to the next line. And then the last line will display digit 4 and it won't go to the next line. So cursor here. Let's do this other one. So this is for the left-hand solution. The right solution looks like the following. Print line 1 will display 1 and then go to the next line because it always does new line after displaying what's in the input. Then it will display 2 and go to the next line. Then we'll print 3, but we won't go to the next line. And then we'll print 4 and go to the next line. And so we end with cursor here on the next line. All right, so those are the solutions to that one. Let's go to math.random. So a student thinks this will return a value between 10 and 20. Explain why this is not the case. What's the largest and smallest value this might return? So I like to imagine evaluating this sort of from the inside out. So math.random is the actual thing that's going to return a potentially different value each time this runs. So the smallest thing, math.random, might ever be a 0. And if it's 0, I'd have 0 times 20 is 0, plus 10 would be 10, and then if I cast that to an integer, that would be 10. So the smallest value might be 10. What about the largest value? So the largest thing math.random might ever evaluate to is not quite 1. It can't be 1, but it could be 0.9999999, etc. So if we have something that's not quite 1, and I multiply it by 20, now that value is not quite 20. So it would be like 19.9999999. So let's add 10 to that. So if it was not quite 20, and I add 10, now it's not quite 30. Okay, so if I have something that's not quite 30, like let's say it's 29.99999, and I cast it to int. Remember, casting to int does what's called truncating. So it chops off the decimal. It doesn't round it. It's not going to round up to 30. It's going to literally chop off that decimal. So we're going to end with the number 29. So the largest thing that we might ever have is 29. And I think that's a nice way to think about tracing these, is think about what's the smallest thing this might be, and what happens if you plug that into this expression. What's the largest thing this might be? What happens when you plug it into the expression? All right, what if I want to generate a number between 180 and 200? So let's start with the same kind of formatting here and think about how we'd have to modify it. So remember, the smallest thing, math.random, could be a 0. And so if it returns a 0, this number is going to be the smallest value that this entire expression could become. So if I want the smallest thing to be 180, let's make this be 180. And if it seems weird to put it out there, you don't have to. You could put it like over here, because then you could imagine as like 180 is my starting value. And onto that, I'm going to add a random number that could potentially take me as high as 200. Okay, so if I want to get as large as 200, what's the largest thing this number would need to be? So to get to 200 from 180, this would have to be 20. And great, it looks like I have a 20 here, but be careful. This is the trap. And this kind of question happens all the time on the AP test in the multiple choice section, because it's a very common programming error. Math.random can't be the number 1. So that means this part can never evaluate to be 20. The largest thing this could ever be is 19. It's going to be 1 smaller than 20, because if math.random is 0.99999, so not quite 1, something that's not quite 1 times 20 is going to be something that's not quite 20. So it's going to be like 19.99999. And then casting to int is going to chop off or truncate that decimal part. And so you're left with just 19. And so then if you have 180 plus another 19, that has not gotten us up to 200. And I said we wanted to include 200 as one of the possible values. So does this seem fiddly to you? Yes, very fiddly. But this is called an off by 1 error. So to fix this, I would need to make this 21. Just make it 1 larger. So now this possibly could be 20. And you'll notice that the value that I had before here, 20, was off by 1. I wrote 20, but it should have been 21. Off by 1 errors are so famous in computer science that we've given it a name, an off by 1 error. So it's just one of those things that you want to be aware of when you're programming. All right, get random pair. It has an array of strings as an input, and I'm supposed to return a string as an output. And here's an example. If I have an array consisting of a bunch of individual letters, get random pair is just going to select 2 random elements from the list and put them together with a space, and it said it's okay if both elements are the same. All right, so let's do this one over here in the editor. Let's actually, this is going to be useful to show you. So here, I'm just going to try and paste directly from the doc, and you'll see that it looks like a chaos. If you've never tried to do this before, if you've never pasted in double quotation marks from a document, there are different characters that look like double quotes. So these are ones from a document that's intended to be looked at by humans. So you can see that this one looks slightly different than this one. They're sort of angled different ways to indicate opening and closing. In programming, the editor doesn't make that distinction, so it does not know that these are supposed to be double quotes. So the practical story is don't try and paste double quotes. You have to type in the double quotes yourself, which I am doing now. Okay, so what I'm doing right now is flailing around. I'm trying to recreate the test case so that way when I complete the method, I can actually run it and see if it seems to be doing what it's supposed to do. If you don't remember the shortcuts, this is called programming by intention. I have created the method I wish existed. You see the red is a compile time error. If I put my cursor on it and then hit Alt-Enter, it says create method with the correct return type, although you got to double check this because it doesn't always guess correctly. And then the input type, and then this is the parameter name. All right, great. So what I'm supposed to do is I'm supposed to get 2 random elements from this list. So let's go ahead and get a random element from this list. I'm going to type a sort of verbose version of this first, which means I'm going to include lots of lines. So I'm going to make an int called index1 that's going to be a random location in the list. So math.random times names.length. So the smallest thing this might be is 0, which would be the first location in the list, because remember, indices or locations start at 0 and go up. If I were going to print out what is names.length here, it is 1, 2, 3, 4, 5, because names.length literally tells you how many things are in the list. Oh, this is going to tell me I'm not returning anything. Hold on. So the length of a list or the length of an array tells you how many elements it has. So this has 5 things. Notice that since math.random can't be 1, we can't ever get an index of 5. But that's good because the location that corresponds to the last element here isn't 5. It's actually 4. So here are the location numbers. Here are the indices. This is 0, 1, 2, 3, 4. So the last index is always 1 smaller than the length of the list. But that works out perfectly with math.random, because math.random, if you multiply it by the number of things, the largest thing it might give you is that last location that we might want it to be. So long story short, this is going to give me a random integer between 0 and 4. So in other words, it's going to give me a random location in the list. And now if I want to, I can say names index1, and that's going to fetch out. It's going to get whatever string is in that location and assign it to output. So the next thing I need to do is take output and add a space. If you have 2 strings with a plus sign in the middle, what it does is it concatenates the 2 strings. Concatenate is a word that just means putting them together. So it will have the output string and then put a space at the end of the output string. But now I need another random index. So, well, let's do it verbose first, and then we'll make it a little bit nicer. So I'm going to make a totally new variable called index2 that's going to be another random location in the list. And I'm going to take the element at that location, but instead of defining a new variable, I'm going to take my existing output and append this to the end of it, and then I'll return output. So this is not the best solution yet, but it works. So let's observe it working for a minute. Let's do this. I'm just gonna loop it like 10 times so that we can watch it go. Let's run it, and we should see a bunch of pairs, or in fact nothing at all. Oh, I see. So it ran 10 times. I'm assigning the result, but nowhere did I actually display the result. Okay, let's try this again. Okay, so, it's hard to tell if this is totally working, but I am definitely seeing that I'm getting the first element in the list. I'm definitely seeing I'm getting the last element in the list. This appears to be randomly selected pairs of elements. Okay, by the way, when you're doing homework at home, when you're trying to do these, it's a great idea to try them in the editor because, first of all, it's like you're never actually going to program on paper. You're always going to be programming on the computer, but also it's a great way to see if it works. Okay, so I said this is not the cleanest answer yet. These two chunks feel very similar. So let's do this actually. Here's kind of what I wish I could do. Let's express this more directly. I wish I could say something like this. Return, I want to get a random element from the names list, and then I want to add a space, and then I want to get another random element from the names list. So I wish I could do that. This feels so simple, right? Get an element, space, get an element. It's just that we don't have get random. So let's make it. Nope, I'm not going to import. I'm going to create method get random. It's going to return a string. I take the string array as input. And now let's just do that same thing that we had before. So I can say int I equals int math.random times names.length. And then I can return names index I. So these two lines are the same as what I had before. These will generate a random location and then get the string that was there and return it. Only now I'm doing it twice with a named method. And this makes it a little bit cleaner to read. It makes it a little bit more reusable. These two lines could even be shortened as well if we wanted to. Like arguably we could put this inside here. However, I actually prefer not to do that, and I'll tell you why. Let's pretend that for something this small and simple, it's probably not going to be a big deal. But if this was part of a much larger program where we program a whole lot of stuff and then we run it and we discover a bug, at a certain point, debugging often involves checking the values of variables to make sure that they are the things that we think they should be. And so if I have, hold on, let's do this. So if I have this in here, if I'm running it in debug mode, I don't have a particularly easy way to check what number this is because it's not aligned by itself. It generates the random number and then immediately gets that element out of the array. If I have two lines of code like this, now I could put a breakpoint here and actually look and see what is the value of I before I use it to access the array. Or you could, or you could say I is I. Again, if you want to debug. So I don't think it's always the best idea to write code that's as few lines as possible. Sometimes you intentionally want lines to do only one thing per line because that makes debugging easier later on. Okay, the next subpart is a modification of the previous one. We're going to get a random element from the last n elements, where n is an input. So this is pretty characteristic of programming problems in general. They're posed in an abstract way, and you might think, what is n? And that's why you have to read the examples and sort of think what's happening here. So here it says get random from last n. I give it my list of things that I'm going to be drawing from. And then n in this case is 1. So I'm going to get a random element from the last one thing in the list. and that's always going to be E no matter what. But if I'm going to get a random element from the last 2 things in the list, that could be D or E. If it's going to be the last 3 things in the list, it might be C, D, or E, or if it's the last 6 things. I had actually said that if n is larger than the length of the list, you should return empty string, nothing at all, which maybe isn't the best way to define the problem. To my taste now, I'm thinking, well, if it's larger than the length of the list, then you should just return a random element from the whole list. But an important thing to do in computer science is always follow the specifications that you're given. So let's follow the specifications. So I'm going to keep the same names. For testing purposes, I'll print out 10 examples. And then here I'll have get random from last n, and then names, and then let's just do like 2 as an example, and we can sort of fiddle around with that as we want to. Random. All right, so let's make the method. Yep, it returns a string. Yep, we have a string. Yep, int. Except I don't want to call this I want to call it n. Okay, so I gave you some pseudocode. So let's, I guess, follow the pseudocode initially, and then we can think of a slightly different take on the pseudocode. So the first thing I want to do is test for input values that would make the method not have a defined output. So in other words, if n is too large, then I don't want to do anything. So I'll say if n is larger than names.length, then I'll immediately return empty string. Just a note, if you only have a single line that's supposed to be the body of your if statement, you don't have to include quotation marks, or sorry, curly braces. So I could include curly braces like that. But again, since I only have the single line that I'm interested in, if you leave them out, that syntactically is the same thing. And it's a little bit shorter. Some people feel, some style guides say that you shouldn't do this because it can lead to bugs if you want to modify your code again later. But I think it's okay. All right, so you might also consider testing to make sure that names actually has elements. Let's do that also. So if names.length is less than or equal to 0, then let's also return empty string. All right, so now we've tested conditions that would be sort of failure conditions, like we couldn't do the thing the method's supposed to do. Now let's actually have it do the thing it's supposed to do. So the first thing I want to do is let's find the smallest index that I might draw a random thing from. So if it's in the last n, the smallest index is going to be names.length. Is it going to be minus n? I don't know. We have to think about this. So here, let's go back up here and think this through for a minute. Or actually, let's do it up here. So the indices, or maybe I should explain the whole pseudocode first if you weren't just looking at it a second ago. So here's the sort of pseudocode idea. If I want to select a random element from the last n locations, what I'll do is depending on what n is, I'll figure out what is the index of the smallest thing that counts as being part of the last n. And what's the index of the largest thing that counts as being part of the last n. And then I'll generate a random location that's between that smallest and largest. And that random location will correspond to a random element in the list between the smallest and largest, which is exactly the last n. Okay, so names.length is going to give me 5. So if I'm going to get a random element from the last 2 elements, that's 3. 5 minus 2 is 3. So that makes sense. I'm trying to think what's a way of calculating what that smallest element might, or what that smallest index might be. And I was just thinking through a specific test case. So let's think through another test case. Let's say I'm trying to get a random element from the last 4. What would be the smallest index if I'm getting a random element from the last 4? Let's see. So the smallest index would be 1. How would I calculate 1? It would be 5 minus 4 gives me the 1. So that was me sort of working out with specific numbers what I want in my code. So names.length is that length of the list. I'm going to subtract n, and that's the smallest index I might want. And then the largest index I might want is just names.length minus 1. -1, you're thinking? Ah, yes, remember? Names.length gives me 5. The last index is always 1 less than that. It's 4. And so now if I wanted to, I could generate a random number between smallest and largest and use that to get an element out of the list. There's something so this is conceptually straightforward. There's something a little silly here, which is that the largest index is never going to change. It's always just the end of the list. So if you're calculating something that never changes, there's a possibility that you could do this in a more direct way. So let's try and do that. Here, give me just a second. I hear the door. Okay, I'm back. So rather than find what's the smallest index and largest index, let's do this. Let's calculate a number that's how many do I want to subtract from the last element and still be within the last n. So if I'm within the last one element, then I'm going to start at 4 and I'm going to subtract a random number between 0 and 0 because if it's just the last one, I don't want to move at all. If it's the last 2, I'll start at 4 and subtract a random number between 0 and 1, a random integer that's either 0 or 1. So in other words, if the random number is 0, I'll end up with 4. If the random number is 1, I'll end up with 3. If I'm trying to get from the last 3, my random number will be either 0, in which case I'll be here, 1, in which case I'll be there, or 2, in which case I'll be there. So that's the idea, is let's just calculate one random number, which is how many am I going to subtract from the end and still remain within the last n. So in this case, what did we say? We said if n was 1, we're going to subtract only 0. If n is 2, it's going to be 0 or 1. So it's like we want a random number between 0 and n minus 1. So let's do int math.random times n. I said n minus 1, but we want to include that n minus 1 value, and we don't want to include n. So again, even though this is abstract, you can think about it with specific numbers. So if n was 2, let's say, this is going to give us either 0 or 1, but not 2. And that's exactly what we want. If this were 3, this expression is going to give us either 0 or 1 or 2, but not 3. So it's going to include that n minus 1, that 1 smaller than that n value. Okay, so great. So now all I'm going to do is I'm going to return names, and then names.length minus 1 is the last location. And now from the last location, I'm going to subtract my toSubtract number. Maybe you think the name toSubtract is sort of like a weird name, so let's change it. Let's make it, let's just make it I. Okay, so that'll do it. And I think this feels like a very concise, nice solution to me. All right, let's keep it going here. So I don't know if you've seen these syntactic abbreviations before, but n++ is the same as saying n equals n plus 1. N minus minus, n equals n minus 1. N plus equals 5 is the same thing as n equals n plus 5, and so on. So this is just to kind of test your code tracing. There is, a medium amount of code tracing in the AP test. Is it the most important programming skill in the world? No. I mean, I think it's fairly important when you're debugging. But it's a thing that you'll have to do, certainly. So here's my advice. Over here, let's keep track of the different variables. So I've got an n and I've got an a. So n starts off with a value of 2. Then n++ will increment n. So now n has a new value that's 3. Now, n gets assigned to the value a. So the value 3 gets copied into the a variable. This is not saying that the a variable is linked to the n variable forever. It just executes on this one line. This value is copied inside this variable. So now when I say n minus equals 2, that subtracts 2 from n. So 3 minus 2 gives us 1. But notice that a doesn't change at all. Then a times equals n. This is the same thing as saying a equals a times n. So so a equals 3 times 1 is just still 3. Now n gets set to 1, which is silly because it's already 1. And then a gets 3 added to its current value, and so we end up with 6. So a is 6 and n is 1. But you should be able to do that process, relatively quickly in an error-free way. Okay, so write a for loop that prints the values 303, 300, 297, and so on down to 63. So we're going to start at 303. We're going to end at 63. We're counting down by 3s. So I'll initialize the loop counter I to be 303, because that's where I want to start. Every single time after my loop body executes, this is how I want to change my loop counting variable. So I want to minus equals 3. So I'm going to subtract 3 each time. And then I want to go all the way down to 63. This is a Boolean expression, which means it evaluates to true or false. And it needs to evaluate to true as long as we want to keep looping. So in other words, as long as I is larger than our ending value, that's when we want it to keep looping. So if I is larger than 63, we want it to keep going. Now this contains a small bug because if we count down starting at 303, eventually we'll hit I is 66. We'll display that. We'll subtract 3, so then it'll be 63. Then it'll check, is I larger than 63? And the answer is no, because it equals 63. And so because this is false, we'll exit, and we'll never display 63. So you actually want this to be greater than or equal to. So we want to keep displaying the numbers as long as they are larger than or equal to 63. And so then as soon as it's smaller than 63, we would exit. So an important thing to get this problem right is to know the order in which each of these pieces runs. So first, it runs the loop initialization. Then, before we do the loop body here, it immediately checks to see, is the current I value valid? Does it make this expression true? And if this is true, then we run the loop body. And the loop body is between these curly braces. And then once we get to the end of the curly brace, then we go back up here, and then this is the last thing that runs is we change the loop counting variable, and then we check it again to make sure it's valid. If it's valid, we execute the loop body again, and so on. So we keep going in this order until eventually this is false, and then we exit. Okay, so consider this loop. Why will it not display anything? Well, we initialize I to 0, and then we say, is it true that I is smaller than 0? And the answer is no, because I equals 10. And so we exit right away, and it never runs the loop body even once. What about this one? We initialize it to 10. We say as long as, and then we say, is I larger than 0? And the answer is yes, it's equal to 10. So we print I, and then we increment it. So now it's 11. Is it larger than 0? Yep. So we print 11, and then we increment it. So now it's 12. So you can see we're counting up starting at 10. And so this is just going to continue to be true. If we're counting up, I is always going to be larger than 0. So that's why it's going to loop forever. Technically speaking, it won't loop forever because int has a maximum value it can be. So as soon as I gets large enough, because of the way that integers are stored internally, if you add 1 to the maximum integer value, it will sort of loop back around to the minimum integer value. So you count high enough and integers suddenly become negative. But this is typical of what we call an infinite loop. Okay, for the next problem, it says we've got a list of product objects. That's a list of products. And each product I can run getPrice, which will tell me its price, and I can run getAverageRating, which will tell me what's the average star rating for that product. And so then this method, countProducts, makes it sound like I'm going to be counting products of some kind. I have this list called productList, and I have something called maxPrice and something called minRating. So it says complete the method using a for loop to loop over every element of the list. Test each product to see if its price is smaller than max price and if its average rating is larger than min rating, and then use an integer to count. So I'm just going to program it straight here in the document, which I said you shouldn't do, but it would take a lot of setup to define the class and so forth. Okay, so it says use a for loop to loop over every element in the list. Okay, so there's a typical way of doing this. For I equals 0, I is less than product list, and you might be thinking dot length, because we just did that for arrays. This is one of those things that you just have to reference until you become familiar with it. When it's an array list, the length of the list is called size, not length. So, there it is. So we're going to go from 0 to product list.size, incrementing each time. Let's go ahead and actually store the product into its own variable. So I'm just going to call it P for product. And I'll say product list. If this was an array, we would use the square bracket notation to say, give us element I. Because it's an array list, we have to say .get I. Different syntax, looks different, but it means the same thing. It means give us the element of the list that's at location I. And so that gets it out of the list and saves it inside P. Okay, so now we have a product. What are we supposed to be testing it for? It says test to see if its price is less than max price. So to do that, I'll have if P, how do I get the product's price? Aha, well, we have a method getPrice that the product class can run. So since P is our product, we can say P.getPrice, and that will return the price. And we want to make sure that that's larger than, we want to make sure that that's smaller than max price. Is that right? Yeah. And then we also want it to pass another condition. So let's have ands here. So we're going to test if this thing is true and also if another thing is true. So we're also going to test if P.getAverageRating is larger than min rating. So this getAverageRating is asking product P what its rating is. And then I'm going to compare to see if that's larger than the minimum rating that I want that's up here as an input to my method. And if both those things are true, that means this is a product that I want to count. Because remember, I'm returning an integer. You can see here that the return type is int. So we didn't define a variable for this yet. So let's define an int called count that starts at 0. Here I'll have count plus plus. And then at the very end of the method, I will return count. And that's a very generic, kind of straightforward approach for this very, very common type of task. Okay, in this problem, we're going to assume that there is it an array or an array list? No, we have an object. The object is called wordList, and it has a method called getRandomWord that will return us a random string of some kind. So like maybe this is, a list of 10,000 words, and this is a way of just getting random words out of the list. So you can test the length of a string by running length. So for example, omnom.length has a length of 6 because there are 6 total characters. Because remember, space counts as a character. And so there's 6 total things here. Okay, so what are we supposed to do? We're going to write code that involves a while loop that will run getRandomWord over and over again until eventually we get a word that's longer than 6 characters. I want to count how many times I had to fetch a word before I got the one that's long enough. And then we're going to display a message that says, like, it took me this many tries to generate the string. And then this is an example of what would be the thing that I got that's longer than 6 characters. Okay, so rather than just do a perfectly correct solution right off the bat, I'm going to pretend I'm a student who sort of has a vague idea, and I'm going to kind of illustrate what it looks like to think my way through the problem if you're not sure what to do. So we know we need a while loop of some kind. So I'm thinking I'll have a while loop, and it's pretty normal to have to just write template code with the stuff that you think you might need, but you can leave parts of it blank. So I don't know what this while condition should be yet. But I do know that I want to be getting random words, right? So let's get a random word. I can't just say get random word because this is a method that only a certain kind of object can run. Only a word list can run this method. So let's say wordList.getRandomWord. And if I'm saying get random word, I need to save that word somewhere. So let's make a string called word. So now I'm getting the random word, but I'm assigning that random word here. Okay, I put this inside the while body because I want to be doing it over and over and over again. I want to keep doing it until I get something that's long enough. So I might think something like this: while word dot length is greater than 6, keep getting it. Okay, so there's a couple things wrong here. One thing that's wrong is I'm actually defining word for the first time here, but I try and access word's length on the line before. So I actually need to create word earlier on, like this. And then in here, I don't want to say string word again, because that would be trying to create a completely new variable, also called word, that's also a string. And it would say you can't do that. It's a duplicate. So I don't want to create the variable word here. I'm creating it up here. Inside the loop, I just want to assign it new random words. Okay, so that part's fixed. I've got this word that starts out as nothing. And then inside here, I'm going to randomly assign new words. Okay, here's the other problem. Read this as English. You can think about while as saying, repeat this stuff while this is true. So do I want to keep assigning words while my word is larger than 6? No, because when my word is larger than 6, that's when I want to stop. So I have this backwards. I want to keep assigning words while my word length is smaller than 6. So that way, I guess smaller than or equal to 6, because it has to be actually longer than 6. Okay, so far so good. So I have this word that starts out as nothing. I test to see, is it less than 6? And the answer is yes. And so now I create a random word. And now I'm going to need a counter. So let's define a counter out here. And each time I assign a random word, I want to add to the count. So now I'm going to be looping, counting. And then eventually I'm going to get a word that's long enough. And I'll say, is my word smaller than length 6? And the answer will be no, because I'll have a long word, like consideration. And when that happens, the while loop is done, and so it will jump down here. And now I can print out, what am I supposed to print? So it's took, and then here I'm reading from here, 37 tries, but right now count is the thing that's counting my tries. So it took count tries to generate the string plus word consideration. Wait, did I screw this up? Yes. Okay, great. Cool. And I think that works. I guess here it says, okay, I told you should follow the spec, so I'm going to follow the spec also. The spec says we should display this extra bit at the end. Okay, there. Now it is the spec. So this is a good word, and what I wanted to illustrate here was maybe you felt unsure about how to start this, but you can kind of grope your way forwards. Think about template code. You know you need a loop. Okay, if you don't know what the loop condition should be, think about what needs to happen inside the loop. Okay, you know you need to get a random word. How does that work? And then think, okay, so random word has to run on this object. So you can kind of think it through one step at a time. I didn't start out with the count variable. I only realized I needed that once I'd kind of thought it through enough. And so I went back and I inserted this at the beginning. So it's not a process where you start with line 1 and you write it correctly to the end. You might bounce around and you're continually imagining you're the computer running the code in your own mind. And that's how you eventually fill in the parts correctly and you catch things that are wrong. Like we had this originally, and thinking it through carefully convinced us that that was not right. Okay, I think we're almost at the end. This was way longer than I thought it was going to be. Okay, so we're going to define a person class with a tester. So the person object should have the following attributes. That means variables. So people are going to have ages and names, and a Boolean for whether they're messy, and a Boolean for whether or not anyone they date needs to match them in messiness. So true would mean that their date needs to have the same messiness as them. False means it doesn't matter to them. Okay, so let's go. So before we think about methods, we just said variables. These are like facts about the new type of object we're trying to define. So here, let's go and do this back inside an editor. Okay, this is something where IntelliJ can really help you out a lot. So here I'm going to make a new Java class. I'm going to call it person. It's conventional that all class names start with a capital letter. So public class person is now defining what does it mean to be a person object for us. All attributes should be private unless you have a specific reason why it's okay for it not to be. But right now you don't have that. So we're going to talk more about this when the year starts. But for now, make all your attributes private. What did I say we need? I said we needed an age. I said we needed a name. And I said we needed a Boolean that was, are they messy? And then another Boolean that another Boolean for should their date be the same messiness level. I'm not convinced this is the best name for this. It's pretty conventional to define one variable per line, but it's also totally okay, and you'll see this in other people's code. As long as your variables are the same data type, you can define more than one on the same line. Okay, so now let's make a constructor. It's good to be able to write out your own constructor, but if I hit Shift and start typing constructor, I can generate my own constructor using those attributes. And so there's the constructor. Public, and then there's no return type, not even void. And then person has to match the name of the class. That's how we know it's a constructor. And then I have a series of inputs that are going to give me the initial values that I want a new person to have when I create them. Because that's what a constructor does. It creates a new example of a person object. And what it means to create a new person object is to give their variables their starting values. So the inputs are going to be, what's your starting age? What's your name? Are you messy? Do you need to date the same? And so we're going to take each of these inputs. Notice in the editor here, if I click on age, see how it highlighted that input age? And then if I click here on this dot age, it's highlighted the attribute age up here. So this is a way of saying we're taking that input number and assigning it to the attribute up there. All right, so we've got a constructor. Let's go ahead and look at what methods we need. Okay, we should have getter methods for all attributes and a toString that gives us the attributes in an easy to read way. Okay, so getter methods, again, you should be able to do this by hand. So a getter method, the purpose is to have a method that returns one of your attribute values. So I'd say like public, if I'm gonna let people get the age attribute, age is an int, so the return type will be int, get age, and then I'll just return age. You could type this dot age to be explicit that it's one of the attributes, but you don't have to unless there's an ambiguity. Here I have two age variables. This is called age, and then the attribute is called age. So if I want to assign age to age, I can't do this, because what does it mean to assign age to age? The computer can't guess which one of these two age variables you want to assign. So if there's ambiguity, if there are two variables with the same name, then you would need to do something that involves the keyword this. Down here, there's no ambiguity, so I can just say age, because only the attribute matches the age variable name. Okay, so you could do that, or you could hit Shift, type getter, and then let's auto-generate the rest of the getter methods. Ta-da! Let's make a toString. So a toString method always has the name toString with a lowercase t and a capital S. The return type is string. And this is what we want to display if we put a person variable inside a print statement. So I'm going to print name is age, years is messy, and then plus is messy, and that's going to be true or false. Date same messy. Okay, so I'm constructing a string here. Let's zoom out. So again, this is for humans to read. So all I really want to do is return a string that will make sense for humans to read that includes all of the attributes. All right, so let's see what else we need. Okay, the next method is called canDate. So it's going to take another person as input, And the purpose of this method is to decide, can the person object running this code, is that person allowed to date this other person? And to do this, we're going to use a common mathematical rule for socially acceptable dating. So here it says, if the person running the method is younger than 14, return false. They cannot date. That's what my mom said. No dating younger than 14. Otherwise, you're going to calculate the minimum and maximum acceptable dating ages based on your own age. So you take your own age, divide it by 2, and add 7. And that's the youngest that you can socially acceptably date. The oldest you can socially acceptably date is your own age minus 7, and then we'll double that. And so that gives us the boundaries of social acceptability, and then we would want to get that other person's age and say, is their age between these two numbers? Is it within the bounds of acceptability? So let's go ahead and implement it. Okay, I can't remember all that I just said, so I'm going to reference it on my other screen here. The method I'm writing, I like to have toString as my last method in the class. All right, so the method I'm writing is called canDate. It returns Boolean, like yes or no, can I date them? Here's canDate. It takes another person object as an input, which we'll call other. So first let's test if our own age, if this.age is less than 14, return false. Otherwise, let's calculate min age. So the minimum age I'm allowed to date is my own age, this.age, divided by 2 plus 7. Let's calculate max age that I can date. This.age minus, it says minus 7, then double that. Okay, this would be a bug because the order of operations don't have me subtract 7 first and then double it. The order of operations would do 7 times 2 first as 14, and then it would be my age minus 14. So we wanted to subtract 7 from my age first and then double it. So you would need the parentheses there. And so now you could do this. If other.getAge is greater than min age and other.getAge is less than max age, I don't think I specified what happens if the other person's age is right on the border. For the purpose of this problem, I don't actually care. So if both these things are true, if the other person's age is larger than min age and smaller than max age, that means they're in the right interval. So we can return true. It's okay to date them. Otherwise, we can return false. There's a slightly shorter thing we could do here. Notice that in order to determine whether we're going to run this line of code or this line of code, what the computer does is it checks to see, is this statement true or false? If this statement is true, if the if statement is true, then we run this and we return true. If the if statement were false, we would run this line to return false. So notice that the value that we're returning is the same as what this evaluates to be. If this was true, we're returning true. If this was false, we're returning false. So a different thing you could do, you could say this, Boolean is okay equals, and then you can just have this as a Boolean expression here. Because remember, this is going to evaluate to be true or false. So now, when we hit line 34, on the right-hand side, we'll do the same thing that it would have done with an if statement. We'll say, is the other age larger than min age? Is it less than max age? It's going to be true or false. But it's not an if statement anymore. The true or false value gets assigned to is okay, and then we return that directly. Or if we wanted to, we don't even need the extra variable. We could just say return whether or not this is happening. And that's a kind of a shorter way of doing the same thing. Okay, so now we've got our canDate method. Let's see what's next. All right, so we want to see is the person object running the isMatch method a good match for this other person. So the first thing we're going to do is run the canDate method to see, can I, the object running this code, date the other person? Like, is it socially acceptable? And if not, then it's not a match. So we're going to return false. presumably we want this to be reciprocal, so we would want the other person to run candidate on us. I don't know, maybe I left that out on purpose. Let's keep reading. Otherwise, to be a match, it must be the case that both partners' messiness is acceptable to the other. In other words, if either person said their date's messiness needs to match their own, then you need to check whether that's true. Okay, that makes sense. So let's implement this. Start with the method signature. It's got a Boolean return value. It's called isMatch because we're testing, are we a match for somebody? The person is called other. So the first thing we want to test is if candidate other equals false, then we'll just right away return false because we don't even need to check messiness. A more conventional way to do this, a shorter way to do this, is not to check if it equals false. It's to use the not symbol. This operator does the logical opposite of whatever true or false value this is. So if candidate returns true, this is saying the opposite of that. But you can read it, if that's confusing, it reads very nicely in English if you think about this as not. So you can say, if it is not the case that I can date the other, then return false. Okay, and like I said before, it means the same thing as if we said can date equals false. All right, so if we cannot date them, then we'll return false. We're not a match. Otherwise, let's see, if either person... Let's think about it this way. So if both people said that they don't care if their date is the same messiness level, then it doesn't matter how messy anybody is. You know, they're just a match right away. So we only need to do more checking if somebody said that the messiness level has to match. So let's do that. So if this dot date same messiness is true, or if other dot get... do we not have a getter for that? Okay, let's pause this. Public Boolean. So getters usually start with get. The wording here is a little awkward. So like get messy matching requirement. It's kind of wordy. I guess we'll keep it the way it is. Sometimes getter methods are phrased more cleanly if they don't have the word get. So maybe instead of get messy matching requirement, must have same dating messiness. That's still wordy. Okay, I don't have a good solution. Okay, screw it. Let's go back to what it was originally. Okay, anyway, so we have a getter method for that now. So now we can write the method we're trying to write. So if it's the case that I need my partner to be the same messiness level as me, or if the other person has a messy matching requirement that's true. So if either of us require that, then we got to do some special extra matching. If neither of us have that as a requirement, then I can just return true at the end because it doesn't matter. Okay, so if somebody has a requirement, then we have another thing to check. We have to make sure that we both have the same messiness. So a kind of a worse way to do this would be to say, like, if I'm messy and the other person is messy. So if we're both messy, then that's okay. We can return true. Or if I am not messy and the other is not messy, then we also match. So I can return true. Otherwise, it must mean that we have different values, so I'll return false. So this is like testing the three possibilities. Either we're both messy or we're both not messy, or one of us is messy and one of us isn't, in which case we don't match, so we'll return false. So this will work, but it's a little bit more direct to do this. We just say if this is messy doesn't equal other.isMessy. So this is like testing, is it the case that these two have different values? Or we could do this. Let's test if they have the same value. So if they have the same value, this would mean either they're both true or they're both false, then we can return true. Otherwise, we can return false. And this is the same situation as before. Instead of having an if statement, we could say, we could define a Boolean variable called like, are we the same? So same is going to evaluate to the result of, do we match in messiness? Is my messiness equal to their messiness? And so then we could just return whether or not they're the same. So if we have the same messiness, yes, we're a good match. If we are not the same messiness, then this will be false, and we'll return false for we are not a good match. So you could also do it that way. Whew. Okay, we're almost done here. It says, write a tester class, make an array with 100 person objects. They can all have the same name, but you should generate random ages between 12 and 65 and other things. Okay, so let's do that. Okay, so here I am in main. I want a list of 100 person objects, so I'll make array list. It's going to hold person objects. You have to import array list, so a good way to do that is to click on array list and hit Alt Enter, and that has inserted this line which says import java.util.arraylist. What goes inside the triangle brace is the data type of the variables we want to be in our list. So we want a list of person variables, so this will be a array list of person. Many persons are called people, or we could say person list. I like people. And then new array list. Okay, so now I said I wanted 100 people, so I'm going to loop 100 times. And now we have to run the constructor. So the way to run the constructor, here, let's do a split screen so we can see at the same time. So here on the left is the person class, and you can see the constructor requires an age and a name and is messy and so on. So I could say person P equals new person, and I'd have to give it an age like 15 and a name like Marl Babak, and is messy. Definitely Marl is pretty messy, and Marl doesn't care if their dating partner is the same messiness. So and notice in IntelliJ it actually tells you the names of the parameters that these values are getting assigned to, so that's like really nice for this editor. Okay, but I don't want all 100 people to have these exact values. I want them to be random. So let's do this. Let's define an age that will be a random age. And I forget what I said. I said, hold on. Okay, so hold on. Okay, so it's between 12 and 65. So 12 is the smallest thing age might be. And then on to 12, we'll add a random number between 0 and 53, which would take us all the way up to 65. Okay, so we've got a random age. So now we'll say age. And because this is inside a loop, each time we run this line, we'll get a new age. And then each time we make a person object, the age that we pass as input for that person will be different. And so each person will get assigned a different initial age. We will always name them Marl Babak because that's a good name for anybody. But we do need random values for is messy. Let's do a kind of a longer way and then a shorter way. So I could say, well, if I want to do a really long way, I could do this. Let's do this. So int flip equals int. So like, let's imagine a coin flip. Math.random times 2 is going to be either 0 or 1. And so now this number is going to be either 0 or 1. And we could say Boolean messy. And then I could say if, let's have them be messy by default. And then we'll say if flip equals 1 instead of 0, then we'll set messy to be false. So now sort of like half the time they'll be true messy, half the time they'll be false messy. So we'll generate an integer that's 0 or 1, and then we'll kind of test it. This is probably not the best way to do this. So let's do another way. So slightly better would be this. So math.random by itself is between 0 and 1. So if we test if it's less than 0.5, that's going to be true 50% of the time. And we don't even need to save a variable. So we could say if math. So let's do Boolean messy is false, but if math.random is less than 0.5, which happens 50% of the time, then let's set it to be true. So this is a little bit better. Let's delete the rest of this. So that works okay. But notice that if this is true, then we want to assign this to be true. Otherwise, we want it to be false. So an even shorter way to do this would be like that. So whether or not messy gets set to true is just the result of this Boolean statement. So think about this like an if statement. So if math.random is less than 0.5, if that's true, this evaluates to true, and so messy gets set to true. If this is false, then messy gets assigned to false. So that's like a very succinct way to do it. And you could actually embed this directly here in isMessy, but I don't think I'm going to do that. I think I'm going to keep separate variables separate. So must match equals math.random less than 0.5. So same thing. And then this is must match. Great. So now we're looping 100 times, but we're creating people with some random properties. What are we testing next? Okay, so it says write another loop which loops over everyone in the array, starting with the second person, and displays anyone who's a match for the first person. Okay, so we're going to find that person all their possible dates. So let's do another loop. Except instead of going up to 100, I'm actually going to say people.size. Oh, this reminds me that I have a problem. Let's go back. So I've looped 100 times. I've made 100 person objects, but nowhere did I say that we should add those person objects to the list of all people. Forgot that part. So people.add p. And so what that does is it takes person object p and it puts it at the end of the people list. And that's what's nice about array list. When you create the array list, it's empty. It's empty even if you do something like this. Some students see initial capacity and they think, oh, I've made a list of size 10. No, that's not right. You've made a list that's length is 0. Initial capacity is different, and we'll talk about it probably later in the year. Okay, so now we really have a list of 100 people. So now let's loop over the list, starting with index 1. Index 1 is the second thing in the list, because the first thing in the list is index 0. So person other equals people.getI. So I is like the location number, and I'm saying let's get the person object in that location, and let's save it inside a person variable. And I want to be comparing it with the first person. So I'm going to define a person variable called first outside the loop here. That'll be get index 0. And I'm not putting that inside the loop because I just want to do this one time. Like I don't need to keep getting out person 0 over and over again. And so now I want to test if they're a good match. So I want to test if first dot, what's it called, is match. If first is a match with other, then did I want to count them or did I want to print them? It says display. So I'll just display other. You might think I'd say other.toString. And you could do that. You see that works out just fine. But that's what's magic about toString. ToString is a special built-in method that is run automatically whenever an object variable is inside a print statement. So you don't actually need to run it. It will just run by itself. All right, let's run it. Or let's do this. First person is, like, I want to know who we're trying to find dates for. Okay, and then we'll find the dates. Here we go. Okay, so first person is Marl Babak. They're 65. They're messy. That's true. It's also true that they must have a partner who is messy. So who can date them? So a 40-year. So one thing I'm noticing is there's no one like really young here, so that feels right. I'm also noticing that everybody in the dating list is also messy because the person who we're trying to match for says yes, their partner has to match them and they are messy. Let's run it again and see if we can get a different set of outcomes. Okay, so here's Marl Babak is 52. They're not messy, and they don't care if their partner matches them. So now you see the matching partners are sometimes messy, sometimes not messy. But whenever they are messy, they don't need to have a partner who matches. And again, I'm not seeing anybody like very, very young here. 36, is that still in the range? Should maybe do that calculation. Okay, I think that's the end. Oh, I see. Write another loop displaying anyone who could date the first person but who isn't a match. So let's just modify this. So if they could date the first person, then that means first dot can date other is true. But also it's not true that they're a match. So everything else is the same. I'm looping over everybody. I'm getting each person out. I'm checking to see if the person sort of is in the right age range for dating them. But it's also true that they're a bad match for each other. So this is sort of like everyone who I could but don't want to. And I don't know. You can run this and test it for yourself. Okay, wow. This took a long time. I hope it was helpful. I'm excited to see you guys soon. Have a good weekend.